Are we ready to start? All right, today we're going to talk about autonomy within standardization. I'm Zacks. I work for the QE Ops team. I've been with Red Hat for 2 years. I started on the 1st of January 2015. A lot of people are surprised when I tell them that I've only been at Red Hat for 2 years because a lot of people have heard of me. That's because I make a lot of noise. And the more noise you make, the more people know you. And that's a good thing. I'm going to try not to put a lot of words on the screen because I know that a lot of people don't like to read. So let's get started. Last year at QE Camp, I heard a number of different talks from people who had created different tools to accomplish the same objective. And I was given the task of consolidating these tools and meeting with the teams and working with them so that we could have one tool, because duplication is bad. And that's a very important concept. So I met with these teams, and they were all very open to the idea of consolidation. They thought it would be great if the other projects stopped what they were doing and started working with their tool. They said, what a wonderful idea. They were very open to working with anybody who wanted to do that. But they were not very open to the idea that they would stop using their own tool and work with the other guy's tool. And as I started delving into the nitty-gritty details, we found out that the projects had different concepts to them, that even though they wanted to accomplish the same goal, they did not have the exact same method of doing it. They had different tools that they were interacting with. They had different ideas of how they wanted to do it. And so at that point, the question was, do we want to railroad these teams into doing QE the Red Hat standard way, which doesn't exist today, or whether we wanted these teams to make their own decisions, work in an autonomous manner. So this is not an easy decision because on one hand, as an organization, we require standardization. It lets us focus on innovation instead of duplication and make sure we're in line with our priorities. So we have to figure out somehow of allowing these teams to make their own decisions and come up with an autonomous workflow while at the same time working in a standardized manner. So during the course of this talk, we're going to go on a journey through the importance of why we need autonomy, whereas at the same time we need standardization. How those two work together, how decisions are made, who the decision makers are, including when you are the decision maker, how to collaborate, when to consolidate, and how to work in an interoperable fashion. So this is a very famous design picture, it's a cartoon, that shows disconnected design. It's what happens when people who are not connected to a decision make a decision. And for those of you who are not familiar with it, it's basically a picture of the different things between what the customer wanted and what was designed, planned, and implemented, which are all completely different things. Because it's so complicated for somebody who does not really understand the needs to go and design exactly what it is you need. So I was meeting with the middleware team. They had added an extra work item to their Polarian project. And this was a big issue because we're trying to design Polarian in a way that everybody can use it in a very similar way. And during the course of the conversation, one of the managers I was meeting with said to his BU lead, I don't understand why central config team cares about how we run our business. And that's a very, very important point, because to be perfectly honest, I have no idea how middleware is run. There are significant differences between each BU, also among the products within a BU, and even among the features, so that we can't necessarily come up with a standard way of doing it if they all have their own method. So who should be making these decisions? Or more importantly, who should not be making these decisions? To ask that question more pointedly, should QE staff be coming up with a decision on how you should run your functionality? Should they decide if your test case should be automated or manual? Should they decide if we should be writing scripts in Python or Ruby? Should we be using Selenium or RoboBrowser? The answer is an emphatic no. The person who should be making the decision is the person who's closest to the decision. The person who knows exactly what you need and will make it in the simplest, most efficient manner possible. In other words, you, your manager, your peers, the people who understand the exact issue that we're dealing with. In Red Hat, we have the best and brightest engineers in the market. So we don't want you to be doing some sort of assembly line QE. We want you to be making decisions and coming up with the best way to do things. So if we're going to let you make those decisions, then you can figure out how to do it in the best way possible. However, because we do need standardizations, and we do need the common method of doing this, we need a system of checks and balances. We need to make sure that the way that you're doing it provides the required results that are needed upstream, or uphill, rather, up the hierarchy. We need to make sure that what you're doing doesn't harm the efforts that the QE department is trying to get to. It is following the priorities and of the department. We want to make sure that we have access to understandable metric data. So in order to do that, we do require standardization. Now, most people think of standardization as an idea killer. It holds you down. It prevents you from being creative. It really locks you up. But the truth is the exact opposite. It's that when you don't use standardization, that's when you get locked up. That's when you get imprisoned inside your own idea. And it really prevents you from moving. And I have two examples of this. One example is somebody called me up and asked me for a recommendation for a freelance programmer. And this programmer, he hired him. I gave him the name of somebody who I had heard great things about. He had done a lot of good work. And started working on the project. Everything was great. A year and a half later, the guy calls me up again. And he says, the programmer is quitting, and I need another programmer. And I said, okay, give me some details of the project. And one of the things he told me is that the project was programmed in Haskell. Now, I'm not a racist. I have nothing against off-brand programming languages. But at that point in time, there were only 2 programmers in Israel who wrote in Haskell. And one of them was the programmer who quit. Another example is that at my last company that I worked for, we built a custom ERP system for the company. We didn't start off building an ERP system. We started off building small applications that would support the business as it grew from a 15-person organization to a 150-person organization when I left 10 years later. Now, from one perspective, that was great job security for me because I was the only person in the world who knew how the system worked. On the other hand, Because of this, I couldn't switch to another position in the company, which I wanted to do. If I left the company suddenly, the company would be messed over. And I really liked the company. They were really good to me. I wanted to be good to them. So in the end, I hired another programmer and taught her the system. It was a 10-year system that we had a couple of people building. And it took me a year to train her before I was comfortable leaving the company. 2 years later, she quit. So what we see here is that if you don't have standardization, right? Now the system had a lot of features that you don't find in off-the-shelf systems. It had some great features. It was built with open standards. We couldn't make it open source because the company didn't want to, but it was built with Python and with PostgreSQL, and you could actually go in and see how everything worked. But if we needed to hire somebody who actually had to learn how the system works and figure everything out from scratch, it would be impossible to understand exactly what was going on. So using standardization is freedom. It gives you a lot of extra benefits. It helps you hire people who can come into the organization and get up to speed really, really quickly. It makes your code more maintainable if you're doing things the same way that other people have done it. It makes sure that you're not reinventing the wheel, which oftentimes has you missing an important feature and figuring it out much later because you didn't do it exactly how everybody else is doing it. It's a proven methodology so that you don't have to worry about whether what you're doing actually makes sense or not. Somebody else already did that, and the world has decided that it makes sense. So we have gotten to this paradox of requiring standardization while at the same time requiring this autonomy of people making their own decisions and deciding how they should work. And so now we have to talk about how the decision process actually works to include both of these systems. So at Red Hat, we have a QE hierarchy, which includes 4 or 5 levels. Then if you start off, we have Dave McDonald, the Vice President of QE. Then you have a BU lead, a manager of the product, an associate manager sometimes, and then the quality engineer all the way at the bottom. So the way that this works is that everybody has their own responsibilities and how to do things. Now, in the Bible, on the 6th day of creation, God said, "Let us make man," teaching us that for important decisions, even if you're God, you have to consult with your staff. So how are these staffs comprised? Is that if you look at every level, right? At the VP level, you have QE staff, which is comprised of the managers, among other people, of the BUs. Each BU has its own staff, which is comprised of the BU lead and the people underneath him, the managers. Underneath that, the product staff, and then you have the feature staff, which includes the engineers who are actually doing the work. So what we have here is an advocacy system where every level includes people from the level below it. And so therefore, the best ideas can raise up to the top. So if you have a great idea, you talk about it with your team, including your manager. He passes that on up the next level, who passes that on up the next level. And if you've got a great idea, then it can actually be adopted across the entire organization. Now, are there any managers in here? A couple of managers in here. It is so important to give credit to the engineers who come up with those ideas. It increases your credibility, it empowers your employees, and it really increases the standard. You can take the employee standard, you can bring them up to the meeting on the next level and say, please explain your idea to everybody and answer the questions. And in that way, you're empowering the employees and you're helping them understand that it's their idea, they own it, and they can keep on bringing it up. So how does the staff system work? We have the QE staff, the BU staff, a product staff, and a feature staff. And obviously some teams work differently. There might be another manager, one manager less. But what is each group really concerned with? So the QE staff is concerned with buzzwords and statistics. They want to see the big picture, how everything comes together. They don't really care about the small details, how you do things. They want to make sure that what comes all the way up and bubbles up is the final result. The BU staff is concerned with how their business is run, including the statistics, standardization across their product lines, BU performance, and product performance. The product staff wants to make sure that the products are run correctly, that there's standardization among the different features, right? They want to make sure that the product is run so that people can switch across the different features. They want to make sure that you're not doing something that doesn't make sense to the other teams within the product. And finally, the feature staff, they're concerned with the actual work done, what languages you should be programming in, how the tooling should be done, which methodology you're using, either agile or waterfall or whatever. They're concerned with the actual work, but they have to make sure also that you can do peer reviews, peer approvals, code reviews, things like that across the product. So they want to make sure that there is standardization within that as well. And so with that, we get to the open decision-making framework. Because Red Hat is a meritocracy. In our meritocracy, we make sure that the best ideas win. That the person who comes up with an idea, they discuss it together and purify that idea. Because the best ideas are purified in open debate. It's that when I come up with an idea and somebody says, that's a bad idea, and then I have to defend my idea. I have to come up with why this is a great idea. And then going at this back and forth of whether it's a good idea, somebody else adding in more to that, and the full discussion process. That's what makes the best idea. It's not when somebody comes up with an idea on their own. So if you can work with other people, then you always have a much better idea in the end than if you're working alone. You also have the advocacy system that we just talked about. That because you worked out this idea together as a team, and you all decided that this was the best idea, then it can move up to the next level. So it's not only coming to your level, but after the feature level, the product level is going to talk about this. Maybe our whole product wants to do things that way. Maybe the whole BU wants to do things that way, and it can even get up to the organization level. Maybe all of QE wants to do it that way. However, this should not turn into a mudslinging fight when you're having this open discussion. You have to respect people and understand that even if you disagree with them, respect their ideas. Now, I have 3 strategies that I use when dealing with other people. The first strategy I use is I assume that the people I'm talking to are at least as intelligent as I am. Second of all, I assume that they're trying to get to the same goal that I'm trying to get to. And third of all, and this is the toughest one, I assume that they're rational people that will agree and listen to my opinions if I listen to their opinions and fully take their opinions into account. So, what we're working here in an international forum across language boundaries and geographical borders. Miscommunication happens so often. And you have to understand that most of the time, if you don't understand somebody and he's saying something that doesn't make any sense to you, most of the time you don't understand, because less than 1% of the time, and I did not take statistics, but less than a very, very small percentage of the time, the person talking to you is a complete idiot. All of the other times, if you don't understand what the guy is saying and it doesn't make any sense to you, you don't understand what it is that he's talking about. So I have two examples of when this happened at Red Hat. We had, working on the Polarian team, we had a big disagreement about how to count results. One group, the QE Ops team that I was part of, wanted to count every result that was in Polarian. They said that that's how the system works, is that if you run a test twice, for whatever reason, you have to count that test twice. Another group wanted to only count the final results that were in the system. So if you ran the same test 5 times, he only wanted to count that once. This got to a big disagreement, went all the way up to the vice president's office. QE staff argued about it. When I sat down and understood what both teams really wanted, they wanted the exact same thing. They were arguing about something else, and they just never got to that level to find out what they were arguing about. The question in the end was, what results go into Polarian? Because both teams wanted to count only the final results, the QE Ops team said the only results that should be in Polarian are the final results. And therefore, if you run a case twice, that's because they're both relevant, and so they should both be counted. The other side wanted all of the results in Polarian because he does statistics across his whole line. So he wanted to write a special algorithm to only count the last counts. But since they were arguing about what results are counted instead of arguing about what results go into Polarian, it was impossible to come up with a resolution. Another example is the team I mentioned before that added a work item into Polarian. And this was a big problem because they added a work item to manage their certifications. And they called the work item environment, which accurately described what they were trying to do. Unfortunately, the QE Ops team was using the term environment for something else. We were using the term environment to talk about test run custom fields, which was how you define the environment of what test run you're running. So when we saw that this other team was doing environments in a completely different way, then that was a big problem, because we needed that standardization that everybody's doing their test cases, their test runs, in a similar fashion so we can get the same results out. After I sat down with them and understood what exactly they were doing, we redefined what they were doing as something else. We called their work items certifications, which wasn't what they wanted to call it. It still described what they were doing. It made it a lot more narrow, but it completely removed the opposition to what they were doing because it wasn't conflicting with anything else. So misunderstandings are a big issue. Now, after we have this whole decision-making process, you have to realize that in the open decision-making process, majority does not win. Even if everybody throws down a rock and the manager puts a paper on top, the manager wins. Because you need one person to actually take responsibility and make that decision. And that's the manager's role. Now, with all of this idea of coming up with these great ideas, and now we've had this great idea and we want to build a tool. And you've got to take a deep breath and have a lot of patience, and first you've got to do your research. When you start building tools on your own, that's called silo development. Silo development might be the fastest way to get something up. It might be the most efficient way to get something up. But in the long term, it is certainly not the best way to get things up. Because what happens when you build things in a silo is, first of all, you're not taking into account what anybody else is doing. And therefore, you can't know if you're building it so that other teams can use it. That fosters duplication. Right? If I build things with my method of doing it, and I want to, for example, have metadata inside my test code, and I decide to use RST, and somebody else decides to build the same sort of tool, and he's doing it a different way, with a different format for his comments, those two teams will have a lot of trouble collaborating, and basically we're going to have to start dealing with both of them. As an example of silo development and what it can cause, I had a power user in that ERP system that I mentioned earlier who liked developing his own tools. And he built an entire workflow around the job that he was doing with these tools that he created. He wanted to do an inside outlook with different methodologies. And he did not work in cooperation with the development team. Now, a couple of years later, he switched to another position, and he was training the new user, the new employee who came in, as to how to do the job. But he refused to support the tools that he was building, because that's not his job. He was building them for himself. Any problems that the guy had, he would say, well, go and talk to IT or the developers. And we're like, well, that's not our tools. It ended up causing a crisis in the development that we had to stop our priorities, or stop what we were doing and change priorities to start working on a completely different set of tools in order to build that workflow that was already working and was already well established into the standard tool set, because this guy wanted to build stuff on his own and did not want to work with cooperation. Now, collaboration is obviously a two-way street. It's not only other people who have to collaborate with you, you have to collaborate with other people. So recently we had a team who wanted to start building a tool, and the question was why they didn't talk to me first, because I'm running the tooling group. And the other side of the question was, I knew what he was doing, why did I go to him first and say, do you want to test the stuff that I'm building? Let's see how we can integrate it into your processes. So it's certainly not a one-way street that the other guy has to do collaboration. Both sides who want to collaborate have to understand if you hear somebody's doing something similar to what you're doing, drop the ego, make contact first, and say, listen, we're doing similar stuff. Is there any way we can work together? So when you're about to start building something, or when you would like to start building something, the first thing you want to do is talk to your manager, talk to your BU lead, make sure that other people are not building the same tool. It's very important that we don't have duplicated efforts. We're currently working on the architecture panel. We're working on a proposal right now to come up with a tool registry, a methodology of how we should know if there's a tool built, how the tools should be built. So when you come up with this new idea for a tool, you're going to be in touch with this new proposal, however it ends up working, and making sure that you're building your tool in the correct way with the proper collaboration, with the right partners, and then you can be building it with your idea in the standard way that we need. Also, we need to build things in a modular method, because it could be that today no other teams want to use your tool, but in the future somebody might want to do it. For example, let's say where the example I just had of storing metadata in your code, in your comments. Right? If you build this in a modular method, and you have a front end and a back end of how you process those codes. It's not only good coding standards, it's also a great way that the next time a team does want to do something similar, but they have a different front end, they have different details, they can write a front end and then integrate into your back end so that the end result comes out well. And we also have consolidation. Is that if you have built a tool and somebody else built a similar tool, very often we're going to want to combine those tools. Because according to Gestalt, the whole is greater than the sum of its parts. So as we mentioned, if you have two people with the same idea working on the same tool, and you can integrate your code into theirs, you can then purify the ideas with that open decision-making process, in the open discussion and heated debate, and figuring out which ideas, which functionality should be included. And then you have the entire system together. But sometimes you don't want to consolidate, because there are some ideas that the complexity involved is going to be too difficult. For example, let's say you have the same functionality for two different programming languages. You could technically build a single tool that handles that. But it's possible that it's going to be too complex to be worth what you're doing. So in that case, we have to build interoperable tools. We have to think about it in advance and say, oh, okay, you're doing the same thing I want to do. What functions are you doing? What's your output look like? What does your input look like? Can we use a shared API? Is there any side tools or shared libraries that we can plug in together? And then, even though they're different languages, we only have to build some of it separate, whereas the all feeds into a standard engine. And that way, everybody can use it together. So, we've gone through a long journey of all of the different aspects of the decision-making process, of when we make our autonomous decisions, how that works, how we move the decisions up. We discussed why standardization is so important at the same time as having autonomous decision-making. We learned that the process of making decisions is with the open decision framework, where we can beat each other up on the ideas, which gives us the best ideas, but then the manager or who's ever in charge gets to make the final decision. We learned about collaboration and consolidation when possible, and when it's not possible, build things that are interoperable. And that's all I've got to say about the subject. I'm available for collaboration or conversation at all of these different places, and if anybody has any questions, I'll be happy to take them. All right.